Hey guys, here is my PowerPoint presentation talking about the ATP breakdown during kind of all the different stages during cellular respiration. So I just kind of wanted to put this picture in. It kind of it shows kind of all the different steps. So on the left, I don't know why glycolysis is so dark, but to the left is kind of all the stages of glycolysis, and we can kind of see, the little yellow stars are ATP, these little blue boxes are NAD plus that are produced, and then in the blue boxes it says, what's being formed. Over here we can see, negative 2 ATP, all that. And then up at the top here, kind of the citric acid cycle that takes place in the mitochondria. That picture's a little bit smaller there. Just a nice little diagram of that. And then below that. And so I just thought that was a nice little picture to put in there. And so the first part I'm going to go over is kind of stage 1, talking about glycolysis. So we know that in this step, a molecule of glucose is being converted into pyruvate. And so during the phosphorylation of glucose, 1 ATP is being used. So we're actually being set back negative 1 ATP, going from glucose to glucose 6-phosphate. And then the phosphorylation of fructose 6-phosphate, another 1 of ATP is being used. So we're going back another negative 1 ATP, going from fructose 6-phosphate to fructose 1,6-biphosphate. And on the right, this is kind of just another picture I have that's kind of showing all 3 of the stages again, and then the total ATP production, which we'll talk about a little later on. And so glycolysis continued here. So then we have the dephosphorylation of 2 molecules of the 1,3-BPG, which will give us a gain of 2 ATP. And then we have the dephosphorylation of 2 molecules of phosphoenolpyruvate, which will give us another gain of 2 ATP. And then we have 2 molecules of NADH that are formed during the oxidation of 2 molecules of glyceraldehyde 3-phosphate. And ATP produced from the 2 molecules of the NADH would be 2 times 1.5, which would give us a total of 3 ATP. So in total, during glycolysis stage, we're going to get a total of 5 ATP produced, because we have to take into account the negative 2 from the previous slide that set us back. And so stage 2 is oxidative decarboxylation, or going from our pyruvate to acetylcholine. And so on the right, I just kind of put a diagram. We kind of talked about this, I think it was last week, going from that pyruvate to acetylcholine. And so in this, our 2 molecules of NADH would be formed. And that's kind of about it. And so ATP produced from those 2 molecules of NADH, we would take 2 times 2.5, which would give us a whole 5 ATP. And then comes the citric acid cycle. So over here I just put a nice little picture, like many that we have in our book. And so with this, we get 2 molecules of ATP that are formed from 2 molecules of succinylcholine CoA, and then we get 6 molecules of NADH that are formed in oxidation of 2 molecules each of isocitrate, alpha ketoglutarate, and malate. And then also we get 2 molecules of FADH2 that are formed in the oxidation of 2 molecules of succinate. And so, continuing on with the citric acid cycle, totaling up these ATP. So, out of those 6 molecules of NADH that are produced, you would take 6 times 2.5, which would give us 15 ATP. And then the 2 molecules of our FADH2 that are produced, you take 2 times 1.5, which would give you 3. And then we have a total GTP. So you just take your 2 times 1, which gives you 2. And so all together there, 15, 3, and 2. Put a nice little meme in there. And so on this slide, I just kind of put adding up the totals from glycolysis, we have 5. Oxidative decarboxylation, we have 5, so that's 10. And then during the citric acid cycle, we get 20 ATP. And so that would give us our total of 30 ATP produced during cellular respiration.